Hey everyone. Today is lesson 5, I think, if I remember correctly. Um, Following up from yesterday's video, we're going to be doing the determinant. As usual, I'll be showing you the rabbit hole I went down while doing this myself. Honestly, especially for me, it was extra easy to go down these rabbit holes wherein I'm learning newer stuff because some of this stuff is like already familiar to me conceptually, but uh, it's okay if the rabbit hole going down for you is just the thing and not as diverse as mine, right? But the key is to do so, to expand and see maybe the same thing from different angles, and just try to explore a little bit more uh, than what you need to do for the task at hand. Because it's always easy to just ask ChatGPT or whatever to give you the answer. And I'm using ChatGPT to generate the questions or even this lesson plan in a way. Um, but that's intentional, right? Is to create a structure that allows me to explore and learn in a manner where I am doing and not just consuming, right? As we've discussed, always take the time to just spend some time thinking about it. You know, anything you go over, just feel free to think about it for a little while. Um, yeah, but remember, staying curious is the number one thing. Everything else after that, it's a little different stuff for everyone. I'm not a huge fan of mnemonics myself, like, unless you count like physical actions, because sometimes, like, I'll do a physical thing to remember thing or something small, like whether singular matrices and non-singular matrices are the ones with determinant zero, not zero. So non-zero, non-singular. That's how I remember that, is like the non-non. Because that one's a little confusing because it's the non-singular matrices that it's like the non-non is the one that has the solution. It's a weird thing, but kind of sticks in my head. But I rarely actually do things like that to try and remember stuff. This is something I'm doing very specifically of trying to teach people through this channel. Um, just a little bit, after I go over these things myself. Once again, not super challenging, nothing super crazy, though. Hopefully someday will. I'd like to eventually build past doing all of the basics to doing, like, maybe someday XGB from scratch or something like that. I'm not actually 100% sure exactly how I do that. But today, I think instead of going into the rabbit hole first and then doing the code, I'm just gonna do a flipperoonie and do the code first, and then we'll do the the rabbit hole, right? So I'm just gonna continue from the same notebook we were using last time. We're gonna go def determinant. Actually, for the determinant function, we're not going to use the other functions here of trace, transpose, and all that. Actually, no. I think for let's get into it. I'll remember as I'm doing it myself. But uh, for the next video where I'm going to be doing the inverse of a matrix from scratch, that's where I'm going to need transpose for sure. Actually, I'm thinking about it, I don't think I need trace either way. So let's go def determinant mat, right? So let's see. The easiest thing is it needs to be square. So if, let's say, we're going to use the walrus operator again. If I underscore max colon equals len mat not equals j underscore max colon equals len. And if you guys remember, we're probably not going to if you guys remember, from the dot product video, you can always expand this. And also I mentioned in my previous video, and I'm actually doing it right here as well. And honestly, I could probably bring it out. You know what? Let's just go ahead and bring it out into a different function, like above this. Check. We're gonna call def check square because, you know, why have repeated code, right? We'll do mat colon if, let's actually just copy this like that. Oh wait, I don't think I copied it. Oh, maybe I'm hitting Command C, I think. Hold on. What is going on here? Copy. Paste. Paste. Okay, something is going on. For some reason I can't copy paste, so we're just gonna wing it and do this. Just do it from scratch. Colon equals when mat equals j underscore max colon equals when mat 0 colon raise value error not a square matrix and then return imax and jmax. And since we did that, we can just replace I underscore max comma j underscore max equals check square mat. I'm going to do the same here. Let me see if I can get my copy paste working. Why is this? I'm going to try and just shut off VS Code and do it that way. There you go. That was weird. Alrighty. Yeah, I replaced the check square here. I'm gonna do the same over here. That's actually just something I decided to do willy-nilly right there instead of actually having done that before. Because, you know, why have repeated code? What's the point? It's just like a little thing to think about. These are the kinds of things you want to think about when you're doing these things yourself, is to just, you know, not just try and push yourself to do things like in the doing process, you know, do them or try to do them in the right way. It doesn't need to be perfect, and sometimes if you're tired and you're not going to do it, that's okay. I have done the same thing, honestly, with the validation that I had done in my very first dot product video, but that's okay, you know. But just try. That's the important part, right? So we've checked that this is squared, okay. Otherwise the value error would be raised. Then what do you want to do? So for the determinant of a square matrix, so if I max equals 2, let's say for the square matrix, the determinant is essentially, so if it's A, B, C, D, it's AD minus BC. Right. Let's just double check that. I'm gonna go here, kind of semi-recreating the rabbit hole. Yeah, it's just AD minus BC, that's it. Fairly straightforward. So if I max equals 2, return return mat ad. Oh wait, no, it's but did that wrong. Return mat ad, so 0 0 times mat d mat 1 1 minus bc, so mat 0 1 times mat 1 0. I'm just gonna wrap these in parentheses because I am a little concerned about the order of operations and I don't want to have to rewrite to double check that later. So if I max equals 2, we just return the determinant of that. Otherwise, for the rest, what do we want to do? We want to calculate, so for j max for each column, for j, let's say for j in j underscore max, right? Because I mean, technically, the coding exercise that was generated said to just hard code the 3x3 matrix challenge. I had specifically gone out of my way to try and do this in a generalizable way, just as an extra challenge. So that's the way I'm going to showcase here, instead of just doing the hard code of the 3x3 challenge. Sorry, the hard code of the 3x3 solution. So I'm just going to drink a bit of my water here because I'm really thirsty. So for J and J max, and this is a square matrix, so I could go for I in Imax or J in Imax. It wouldn't make much of a difference. I just went this way because it's easy for me to remember J is columns and I is rows and things like that. So for this, what are we gonna do? For J and J max, we're gonna want to do the well, it's actually for J in range J max, right? We're gonna want to get the determinant of the minor. So let's write a function called getMinor. And I didn't actually even know what the term minor meant, and if you don't, we'll be going through my rabbit hole soon, and you'll hopefully realize by the end of that. Get minor j comma mat, right? So here I want to get the minor. I'm only gonna do, well, the way I did it initially is I hard coded of tossing the first row and then getting the minor from the rest of the matrix, which is useful for calculating the determinant specifically. But for the next episode after this, we're going to need a more generic version where, given any value, we can get, given any index, any element index, we can get the minor relative to that position, which will need to get the cofactor matrix, which will be needed for the adjoint matrix, which will be needed for the inverse, because that's I go the inverse method that I do is the classical adjoint method. Once again, if you don't know any of these terms, that's okay. I'm just going through the code right now, and I'll go through that in a moment when I go through all my tabs and rabbit hole, because I myself, like, I kind of knew these things, because, like, I mean, despite my accent, my schooling was actually in the Middle East, and there's loads of terms that, like, you realized have formalized terms that you never actually learned. You just remembered the rules and the thing, right? Like like the a couple of lessons ago, or maybe it was last lesson, like the thing about Cartesian space was like, I just didn't even know it was called Cartesian space. So sometimes, you know things, but you just don't know what they're called. And so never be afraid. So coming back to this, I'm going to write a more generic version that allows me to get any one. So let's go minor equals mat mat dot copy, or actually we're gonna do mat I colon I plus mat I colon. Remember, there might be some of these things I'm doing from memory because I recently did this, but like this one is a good one where if I was doing this myself for the first time, which I was like yesterday or day before, maybe, I don't remember when. I'm running like a day or two's deficit on these videos in terms of when I'm doing them versus when I'm making these videos. Like, make sure to like just run every line. It's totally fine. Get iterative feedback. Don't try to go down a path that you're not sure. Like, double check yourself at every step. Makes it easier later on. And what we're gonna do is take a copy of this. Now, why are we copying this? Because using dot copy, essentially, since lists are mutable, and if you assign like mat equals minor something something, you're actually not creating a new list. You're just assigning a reference to the original list in the new variable, right? So if you actually want to not mess with that, it's best to just do a dot copy. It's a heavy operation sometimes, so be careful, but like, yeah. So we're gonna do a copy of this. We're tossing the row that was given to us, the I. And I screwed up here because when you're using the slicing operator, it's inclusive on the start and exclusive on the end. So it's like I need to do I plus 1 over there. So that's cool. That is step 1. And then I want to return for V in minor. So for each row in minor, right, I want to get V equals V, basically the same thing we just did, plus V J plus 1. Cool. Right, that's essentially it. And then we return minor. So that's how we get the minor matrix, right? So for J in range J max, now when you're doing the determinant, it flips back and forth between at addition and subtraction, right? So I'm just going to, and the rule that says that you're going from each is I plus j, essentially, right? So it's -1 raised to the power of I plus j, the coordinates of a particular element in a matrix. So I actually did it with an if else and a modulo too, and I did it myself. So I'm just gonna like push myself right now live and think of how to do that with the -1. So -1 raised to the power of. So another interesting thing about unary operators in Python, this, like, let's say raised to 3, I'm just going to say that, is actually calculated like this in many cases, even though what you really intended was this. So, well, not that, sorry, this. So that was a mistake that led to a bug that was really irritating me earlier today in a different scenario that I was trying to attempt, so be careful about that. but -1 raised to the power of, I guess, j plus 2, right? Because j starts at 0, and j is going to iterate through the number of columns, or which is the same as the number of rows, right? And technically it's I plus j, but to do the determinant, it's equivalent to finding the product of the, like, negative times the determinant, negative raised to the coordinate to get whether it's a negatively signed or positively signed, times the determinant of the minor of that element times the element itself, right? Right. And the sum of these in any particular row or column, and generically the first row is what's gotten. So let's do j plus 2. Let's do that. So -1 raised to the power of j plus 2. Let's also set up det equals 0 before this loop, right? Okay, so j plus 2, this part is fine, times the determinant of get minor. Oh, it's a little confusing. Okay, my laptop's acting a little funky. Get minor of I will be 0 in this generic get minor method that I have, 0 comma j comma mat, right? And we times that the actual element, so that would be something like that, mat. Let's just put 0 in there and then j in there. Yeah, that works. And we add that to the determinant, plus equals. And basically I'm just gonna, this way I'm just using recursion to keep coming back into this method until the minor is of shape 2, and then we just like recurse out of it. And then we just return the determinant. I'm gonna copy paste my asserts from a different one. I'm just gonna use these over here. Let's see if these work. Transpose is not defined, so let's just run that first cell first. I think that's probably a good call. Oh, we have an assertion error. Determinant mat -1. It's not a square matrix. How's this not a square matrix? Raising value error. Okay, so I must have screwed up the code somehow. So assert, let me actually view this as a scrollable element. So it enters into this loop, and then it comes back here. And that's when the check square is messed up, which means my get minor is probably screwed up somehow. But how? For v in minor v equals colon j plus vj colon plus 1 colon minor. Let's just debug this live. Print minor. Okay. Which was the assert that failed? Looks like it's the second one. 611 Oh no, it's the first one. So let's just do that. Let's pull that one out separately. Let's see what did we do here. Um, so it's not even getting to this print. It's not getting to the first get minor. That doesn't make sense because this call into determinant this is just a little confusing. This times, just to be very clear, I highly doubt that's the problem, but I'm just gonna, yeah, it's, I'm just gonna flip over to what I did earlier. I don't understand how doing the enumerate here would change it. That's how I did it earlier, but this should still work. Maybe there's some weird thing about slicing. Oh wait, let's try slice assignment so that there's no funkiness happening there. I wonder if that's it. Maybe we can just do slice assignment and oh, it does work. I mean, it's still wrong, but now it's actually entering the get minor loop. Okay. And now it's like not a square matrix. Am I returning Imax and Jmax properly from check square? Yeah, I am. But how am I getting it here? I don't understand why it would 1460 and then it goes back into this loop again. So I have screwed up somewhere in the loop itself or the determinant. What have I screwed up on? In math, plus -1 raised to j plus 2 times determinant of the minor 0j mat. I'm just gonna look at my stuff that I already did. Yeah, I mean, it looks neater here, but it's essentially the same calculation, except instead of doing the if, I just did the mathematical multiplication, which should still work. Well, we are in a pickle, guys, because now we're just gonna live figure this out, and you're probably gonna have to deal with a long video to see what the problem is, unless you're smarter than me and you already figured out what the problem is, which would be irritating. How do we do this? What is the problem? So So the zeroth row gets removed. The jth element of the zeroth row, right, times -1. J starts at 0, 0 plus 2, then 0 plus 3, 4, 5, whatever. For how many? So this is fine. Determinant. And I return it at the end, yeah? Yeah, I return it at the end. Keep adding that to that. So at J1, what's up? Okay. Bye bye, niece. Say hi to my non existent YouTube audience. That was my niece. She wanted to get her water. What I don't understand is why, when we go back, oh, because I'm not doing a copy of my, am I not? I think that might be the problem. I don't understand though why this wouldn't do the copy. Maybe it's because even though I'm doing a copy of the lists, that could be the issue that I accidentally resolved, maybe. That there's something funky going on where I just rewrite the list inside the list instead. So maybe that is actually the issue, because when you do a copy, you're copying the top level list, not the lower level list. So maybe those are still remaining as references. So let's just do it the way I did it before, because I think that might be the problem. Oh, yep, that was the problem. Okay, so my intuition was correct and we resolved the issue. And it's so funny that didn't have that problem while doing it by myself, but when I went rogue, I realized what the issue was. And that's actually a good thing. Like, I just, reinforced a good thing for myself. Now I know that even like the next time I'm in a tricky situation when I'm expecting nested data structures, nested lists, if I just do a copy, it's going to just copy the top level. I guess maybe if I just did deep copy, isn't there a deep copy? Let me see if there's, I'm not sure if this is a thing. Let's see. Okay, yeah, that's okay. Yeah, let's not mess with success too much live. Okay. So yeah, that's the code for determinant. Okay, that's just one assert that's passed. Let's get rid of that print and run the rest of these determinant answers. Oh, there's another print statement somewhere, but the asserts are passing. I have a few more determinant tests that are larger. Wait, what is this? Yeah, this is the correct one. Yeah, I tested out some larger determinant matrices for some larger matrices as well, and they all passed. We're good. That's the code. Sorry for the random delineation from earlier. I'm just gonna get rid of this blank space so that this is neatly in place for tomorrow when we're doing the inverse of the matrix. So to go through the rabbit hole, so to speak, I believe it was around here, because I had pretty early on decided, like, okay, I want to do the proper determinant methodology, and so I just looked up determinants of a matrix greater than 3 by 3, and cofactor expansion or minor expansion, which is the way I did it. Um, uh, the other way is through element operations, but I chose not to go that way, because I feel like when it comes to doing things with element, row, or column operations, I think it's like adding and subtracting the same amounts or things like that. And there's a few others. We're gonna get to that in Gaussian elimination. So I just like stuck with the cofactor expansion method. But the thing is, I didn't actually know that's what it was called, right? And so I was just like looking up the specifics of how it went, how it's done. And that's, I actually didn't even know what cofactor was. I just like read this. I'm like, oh, okay, this seems about right. And I looked up this formula. I'm like, okay, A times the determinant of the minor. I wasn't even sure what a minor was, so I ended up Googling that as well. Well, first I looked up whether it's defined only for square matrices, which made sense like logically. Um, the pop method, I looked up that the dot pop for lists just to, I don't know, I think I at some point I might have been thinking to use it. That's probably why I looked it up, just played around with it. Yeah, and then the copy method, because I kind of intuitively knew the issue with matrices, and I just kind of managed to catch myself on that before I actually ran into some like weird nasty bug. So that was nice. What was this? Oh yeah, some of my asserts were failing from the ChatGPT generated test cases, and it didn't make sense to me. So I started Googling them, which was probably a bad idea because I just got an AI thingy. And then I found like there you go, matrix determinant calculator where I actually punched a few in. And that's because, just like in my previous episode, some of the asserts, like the code that the asserts that ChatGPT wrote for me to test my determinants, like it was just wrong. Not that the asserts were written wrong, it's just that the calculated determinants was completely wrong because this was GPT 4.0, and it's like, don't trust AI completely because, at the end of the day, it's just probabilistic sequence generation, not actual intelligence. They don't understand these things, even though it can seem like it at times. This was me just doing the same thing with O4 Mini High. Now, don't trust this, but also, like, there's a different reasoning why these actually did work. So if you look through LLMs, like with reasoning LLMs, they have like this thinking process. What you realize is with O4 Mini High, unlike with just 4.0, which is what I use to generate the asserts, it's uh, in 4.0 it's just plain sequence prediction. Here it's still that, but basically they allow O4 Mini High to run code in containerized environments. So instead of doing sequence prediction to actually get the determinant, it's doing sequence prediction to write the code to get the actual determinant, which is silly, but yeah, that's what it does. So it does actually give me the correct answers here. And I verified that by double checking with the determinant calculator. Um, and then I started looking into the inverse of a matrix and stuff like that. Um, we'll save this for the next video. Honestly, the main thing, because like this is when I started doing the inverse of the matrix, this whole thing of determinants, like why you calculate them and all that. I mean, one of the reasons to calculate the determinant is to find out whether it's a singular or non-singular matrix, which uh, spoiler alert, only non-singular matrices are invertible and have a unique solution for a linear system of equations. Um, so that is where all this starts coming together. And so I'm just going to save that for the next video because that's where like the real falling into it is. But I'll just leave you with this. When a determinant is non-zero, i.e. it's greater or less than zero, that's when the uh, linear system of equations that the matrix represents has a unique solution. So that's like a neat little thing. And how to do that with cofactor expansion, like why is this method that I implemented as an algorithm for cofactor expansion actually called cofactor expansion, because I didn't know there was such a thing as cofactor matrices, which was dumb because Once again, I come from the Andronic school where you didn't really learn like the math super well. You kind of understood the math conceptually to some extent, and it's like I had linear algebra in school and stuff, and some early college, but it never really stuck. I was actually a pharmaceutical chemistry major, um, and yeah, just want to refresh these things and really dive deep into how all this stuff works for myself. And hopefully for someone else out there too, um, to help you help well myself and hopefully whoever's watching help them level up. Remember, stay curious. Learn by doing. Make sure make sure you're thinking about things. Try and teach someone else. But that first one's the most important thing. Everything else is just follow through and tips and tricks. But you know, go down the rabbit hole, Alice. You know, just see how deep this thing really goes. That was cheesy. Thank you guys for watching. Have a great one.